In previous investigations, you learned what happens when the sun's radiant energy heats Earth's surface. The ocean covers a whopping 70% of Earth's surface. As the ocean heats or cools, how will all that water move? And how will those movements affect weather and climate? Just as there are global wind patterns, there are global water patterns called ocean currents. There are three main factors that affect ocean currents: winds, differences in water density, and tides. Winds drive currents near the ocean's surface. In coastal areas, local winds can drive currents, but in open ocean, global winds drive currents. Deep ocean currents are driven mostly by differences in densities of water. You learned earlier that convection currents form when fluids have different densities. What are two factors that could cause ocean water to have different densities? Which heats up more quickly, water or land? As you learned in Investigation 5, water heats and cools slowly, but even these slow changes will cause temperature differences in the ocean from one area to another. As the sun's radiant energy warms the ocean, differences in temperature will cause differences in density, resulting in convection currents. Which is more dense, a solution with lots of salt or little salt? As you learned earlier, solutions with more salt are more dense. Variations in the concentration of salt, called salinity, in the ocean water causes differences in density, resulting in currents. The combined effect of density differences due to temperature and salinity result in upward and downward flow of water masses. These currents occur both deep and shallow ocean levels and move much slower than surface currents. The effect of temperature and density on currents is greatest in Earth's polar region. As polar sea ice forms, the surrounding seawater gets saltier. This is because pure water freezes and separates from the salt, leaving all that dissolved salt in the ocean. Water near the polar region sinks from being more dense, not only from being cold, but also from being saltier. As this cold, salty water sinks, the surrounding surface water moves in to replace it. Once the water sinks, it travels through ocean basins, eventually coming back to the surface about 1,500 years later. This motion drives the deep ocean currents that weave their way around the planet in a system we like to call the Great Ocean Conveyor Belt, a huge convection current. The third main factor that affects ocean currents is tides. Tides are driven by the gravitational force of the moon and sun acting on the rotating Earth. Near shore, the rise and fall of waters interacts with the shapes of shorelines to create surface tidal currents. Tidal currents follow regular patterns, flooding when the tide moves towards the land and ebbing when it moves towards the sea. The shape of the shoreline can dramatically affect tidal current. The Bay of Fundy between Nova Scotia and New Brunswick is a classic example, with tides over 15 meters or 45 feet, the highest in the world. As you might well imagine, aquatic ecosystems in coastal areas are dramatically affected by daily tidal currents. The movement of ocean water is a complicated thing. Factor in the tides, density changes due to differences in temperature and salinity, local winds and global winds, and the Coriolis effect, and you have most of the pieces of the ocean current puzzle. What's the final puzzle piece? The ocean is broken up by giant land masses of continents and islands. Just as water in a stream will flow differently if you drop in a large rock, the movement of ocean water is affected by the geology of Earth. The pattern of ocean currents affect how fish and other sea life move around the ocean, control how ships travel through water, and sometimes carry swimmers far from the beach if they aren't careful. When surface currents run close to shore, a visitor to the beach could experience a rip current. These local currents form around low spots, breaks in sandbars, or structures such as piers. Rip currents can move faster than even Olympic swimmers can swim, and if you are caught in one, don't fight it. They are generally not more than 25 meters wide, and they usually break up not far from shore, so it's best to swim around them. What causes these gigantic whirlpools in the ocean? Do you notice any patterns in the map of gyres? All the major gyres occur in the middle of the spaces between continents. As ocean currents hit shallower areas of the coast, they start to move in different direction. Think of the water as sweeping along the coastline in a large-scale current, called a boundary current. As the water approaches a continent and then sweeps in a different direction, you get the first part of a swirl that will ultimately form a gyre. A boundary current of the South Pacific Ocean is the Humboldt Current that moves northward along the coast of Chile. As it veers away from Peru, deeper waters upwell to replace the westward moving water. This is one of the biggest upwelling systems on Earth. It brings up cold, nutrient-rich ocean water, feeding an abundance of marine life and the largest fishery on Earth. About 20% of Earth's fish catch is made possible by the Humboldt Current. Because the current is cold, it cools the weather and climate of Chile and Peru. Perhaps the most familiar of the boundary currents is the Gulf Stream in the North Atlantic. It goes northward along the east coast of the United States and then across the North Atlantic Ocean towards Europe. The warm water of the Gulf Stream affects not only the climate of the east coast of North America, from Florida to Newfoundland, but also the west coast of Europe, making for much milder climates than would exist otherwise. We see it every day. Someone carelessly drops a plastic cup or wrapper on the ground as they walk, or tosses it out their car window. Where are those plastic objects now? Plastic doesn't biodegrade or break down in nature. And trash on the ground can get washed by rainwater into storm drains that eventually lead to the ocean. Imagine all that plastic trash floating into the ocean and getting transported far from its source. Where will it end up? About 1,600 kilometers northeast of Hawaii in the Pacific Ocean is the Great Pacific Garbage Patch, a huge swirling current of garbage, mostly plastic. The pieces can be as large as huge fishing nets, but are mostly plastic pieces the size of cornflakes or rice grains, broken from larger plastic objects. This gigantic ocean whirlpool of garbage doubles in size every decade. At the end of 2009, it was estimated to be roughly twice the size of Texas. The garbage is caught in what oceanographers call the North Pacific Ocean Gyre, one of the giant gyres generated by the world's ocean's currents. The garbage includes toxic chemicals. So if it doubles in size every 10 years, and it was twice the size of Texas in 2009, that means by the end of 2019, it will be 4 times the size of Texas. Plastic doesn't biodegrade quickly, but it will break down into tinier and tinier pieces, just the right size for marine life to eat. Fish that feed on plankton eat the tiny plastic particles, and the toxic chemicals from the plastic leach into the fish tissue. Birds, such as the albatross, forage in the North Pacific and eat large amounts of plastic, including fishing line, light sticks, and lighters. Some birds can purge themselves of plastic by throwing it up, but thousands die each year from eating the plastic debris. Sea turtles, many species of which are endangered, may think floating plastic bags are jellyfish and accidentally consume them or eat them, which can lead to death.